Now let's see cascading aborts. If one transaction failure causes multiple transactions to roll back, then it is called cascading rollback or cascading abort. So what is the meaning of this one is, if you observe this, there are three transactions, T1, T2, T3. Now let us say T1 is reading the value of A and then doing something here, right? And then it is going to write the value of A, but it didn't commit it. Before it is getting committed, whatever value it has written, T1, now T2 is reading it, and then T2 is doing some modifications on A and then writing it, but then it didn't commit it, right? Now whatever value is written by T2 is read by T3, and it has done some modifications and it also has written the value there, right? Now look at this. Now T2's value will depend on what T1 has computed, and T2's value will be right provided that T1 transaction is committed, right? Which means if it says that all the changes I made, if they are correct, then only this one will be correct, which means the correctness of T2 will depend on correctness of T1 or completeness of T1. If T1 suddenly says that I am not complete, then whatever T2 has computed will be wrong, right? And then the correctness of T3 depends on the correctness of T2, right? Now if T2 is wrong, then T3 will be wrong, right? So at this point, let us say at this point, before this one and this one has got committed, assume that T1 is saying that I want to roll back because of some failure. Then what happens? Then you have to roll it back, because it will not be correct unless it is committed. Since it is not committing, you two have to roll back and undo all the changes, and now you two also have to roll back and undo all the changes, right? So yes, this is definitely recoverable. The schedule is recoverable, but then the schedule is waste of time, isn't it? Now if you observe this, all the computations done here have to be undone, all the computations done here have to be undone, right? So now what is the solution in this case is, don't read from uncommitted transaction, then you need not do cascading rollback, right? Or if you want to understand it clearly, what has happened here, I'll just tell you what it means. Now let us say T1 has read the value of A, let us say initial value of A is 10, and it has made the value of A as 20, incremented it by 10. Now let's say T2 has started. Now T2 has started from this point, not from this point, right? Assume that all T1, T2 and T3 are three transactions which are trying to increment the value of A by 10. If all of them happen simultaneously, in the correct order, then what should be the value of it? If the initial value of A is 10, if all of them are going to increment it by 10, then it has to be 40 at the end, right? Now let's say T1 has started and it finished it, and it has computed its value as 20, and now T2, it has started and it has started from 20 value, and it has updated it to 30, which means incremented it to 30. Now T3, it has started from 30 and has incremented to 40. Therefore final value computed by T3 is right. Now what happens if T3 commits is, it is going to make this change as final, and then if these two are going to roll back, then you will not be able to undo this change done by it, or the change done by this will be gone, right? Now let us say if they have committed earlier, right? If this one would have committed here, if the commit of this one is instead of this, if it is at this point, then what will happen is, we will consider that T2 has completed its execution and you will not execute T2 again, right? Now if you are going to roll it back, then what happens? It has read the value of T1 has read the value at 10 and it made it to 20, therefore it will again set it back to 10, right? Which means T2 is over, and now T2 is setting it back to 10, and let us say T3 is not over and T3 is able to roll back. Then what happens is, T1 will again come for execution because it rolled back, and T3 will again come for execution at later point in time, but only value of 20 will be incremented, right? By 10 by this and 10 by this. Next time if everything goes well, then the value of this one is going to be 30 only. Got it? So having recoverable schedules is important, For that reason, we are not going to commit any transaction, this transaction, until this transaction has been committed, right? And we are not going to commit this transaction until this transaction has been committed. Fine. And it is going to lead us to cascading rollbacks, right? So what is cascading rollback is, if this one is going to roll back, then this one also has to roll back. Now this is going to be a waste of CPU time, isn't it? So we want transactions which are cascadeless. So what are cascadeless is, even if it rolls back, I don't want to roll back. Got it? So when can that happen? Now let's see this example. Now let us say cascadeless schedule. A cascadeless schedule is one where each pair of transactions Ti and Tj, such that Tj reads the data item that is written by Ti, then the commit operation of Ti should appear before the read operation of Tj. So what they are trying to say is, now in the earlier case, we have to roll it back because we are trying to read the data and perform the operations before this one has committed. Now how can you avoid it? If you would have waited till transaction T1 has committed, then there would have been no reason for you to roll back, right? So don't read data from any uncommitted transaction. Just wait till it commits. So later at some point, if you read it, there will be no need for you to roll back because it is already committed. Anyway, it is not going to roll back. Therefore, there will be no need for you to roll back, right? Similarly, if this transaction is reading the data from this, then wait for this read until this transaction is going to commit. Now once it is saying that I'm done, I'm complete, then only you read it. Why? Because there is no way it is going to roll back. Therefore, you will be safe. Got it? Now how to ensure it is, so if you are going to read from some transaction, see that its commit will appear first. Got it? Now let's compare this one with recoverable. So what does recoverable say? Recoverable say that whenever you are going to read from some transaction, see that you commit only after he commits. Now since you are putting this read after commit, definitely you are ensuring that the commit will be after this commit. Are you getting this? See, in case of recoverable schedule, what was the rule? If you are going to read, let us say there is T1 and let us say there is T2, right? Let us say it is writing the value of A and you are going to read the value of A, right? Now it is saying that let this one commit, then only you commit, right? So this is the order you are supposed to maintain. Got it? This is what is recoverable schedule mean. Now coming to this cascadeless schedule, what it is trying to say is, you put this after this. So by ensuring that the read operation itself is after the commit operation, you can ensure that the commit operation of this one will definitely be after this commit operation. Getting this? Therefore, what can we say? If a transaction is cascadeless, then definitely it is already recoverable. Why? If you are going to order the read operation after this commit, automatically this commit operation will be after this commit. Therefore, it is satisfying the rule of recoverable schedule. So what can you say? Every cascadeless schedule is recoverable. But can you say that every recoverable schedule is cascadeless? No. Why? Because of this, isn't it? This is recoverable schedule, but then you are reading before it gets committed. Therefore, if it rolls back before, at this point, if it says that I want to roll back, then you are supposed to roll back. Got it? Therefore, if you are trying to see the relationship between cascadeless and recoverable, it is like this. Set of all recoverable schedules and set of all cascadeless schedules. Now, every recoverable schedule, set of all recoverable schedules and set of all cascadeless schedules. Now, we can say that every cascadeless schedule is recoverable, which means if you are going to say this is definitely recoverable, but then there can be some recoverable schedules which are not cascadeless, right? So what does it mean? The recoverable schedules may also contain some rollback schedules, right? I mean that cascading rollback schedule. What is the meaning of it? If you are going to roll back a transaction, then you might have to roll back the other transaction. That is not a problem, but just a waste of computation time. See, always it is better to have recoverable schedules, because if something wrong happens with one transaction, you can start everything once again without losing anything. That is why recoverable schedules are important, right? And if you can make the recoverable schedules as cascadeless, it will also save the CPU time. It will not waste CPU time. Got it? Okay.